Before we go on to make vectors more interesting, let's first review real quick what we already know about vectors. The thing we know, number one, about vectors is that if they are in the same axes, we have vectors A and B, or they even point in the opposite direction, but they're in the same axis. Both of these are in the x-axis. We can simply add them. A vector plus B vector gives us C vector, or in this case, A vector minus B vector gives us C vector. That's rule number one. If they're in line, you can simply add the vectors. Number two is that if the vectors are at right angles to each other, vector A, vector B, we can combine them to get some other vector lifted at some angle theta. So when we do that again, I will repeat this enough, I guess, by going tip to tail. It doesn't matter which one's tip to tail you go. No, you remember previously I had gone the horizontal to the vertical, but you can do vertical to horizontal. You'll get the same result of C up this way. Lifted at some angle, theta. And to get the magnitude of C, you take the square root of A vector squared plus B vector squared. And to get theta, you take your arctan, or your tan inverse, however you like to think of it, of your B vector over your A vector. And this will give you your angle above the x-axis. If you wanted your angle away from the y-axis, you'd flip your tangent. If you want to say get phi in here, then you'd have to flip A and B, because now A is your opposite if you're trying to get this angle here. So those are the first two rules, and then our third rule that we came up with in a separate video was that we can take vectors apart. If you have a vector C up at some angle, lifted above some angle, and it's not in the x-axis, it's not in the y-axis, it's just pointed out there at some angle. We can break that into components. We can get a Cx, and we can get a Cy. And we had said that to get our different components, we'd go C sine theta will give us Cy, and C cosine theta will give us Cx. And if you don't remember how to do this, or how I derived this, I derived it in the components of vectors video. Now, using these three rules, we can solve any problem involving vectors in 2 dimensions. Let's do one really good example of how to use all three in one problem. Supposing you've got your x-axis, well, y-axis in this case, here's your x-axis. And you've got a vector A directed along the x-axis, A. And we have a vector B which is directed up and away at an angle of 125 degrees from the positive y-axis, and that's our B vector. And we want to combine these. We want to find out what the resulting vector is. Well, at first glance, it looks like none of our rules apply. They're not at right angles to each other. They're not in line with each other. And At first glance, taking them apart seems to add more pieces instead of taking pieces away. But what we can do is if we take B and we break it into its pieces, we use rule C, being 3, on the surface it looks like it makes the problem more difficult, because it seems as though you'd be adding pieces. So here's A. And let's say that we break vector B up into its vertical, this portion over here, B, Y, B, Y, and horizontal components. It also has a horizontal component. Well, X. Now what we've gone and done is we have vectors in line, Bx and A, and we have vectors at a right angle. So now we can use our first two rules to very simply solve this problem. So let's go ahead and we'll add some numbers. Let's go ahead and say that vector B is 70 units, and vector A is 100 units. So let's go ahead and we'll take this one step at a time. First thing we're going to want to do is combine the ones that are in line. Combine the ones that are in line. So we know this is 100. We don't know what Bx is right off the bat, so we have to figure that part out. Let's draw ourselves a little triangle where we got B, which is 70, Bx, which is 70 cosine of theta, here's theta, and we have By up here, which in this case is 70 sine of theta, and we just pulled those out of right here. Well, what is theta? We know that if we go all the way from A all the way over, this has to be 180. And going this far is 125. That means that our theta inside there has to be 55 degrees. So by applying this formula and this formula, we find that By, as it turns out, is 57.3, and Bx is 40.1. So now we can combine the ones that are in line. Bx and and A point in opposite directions, so we know we have to subtract them. Excuse me. A vector minus Bx vector equals some resulting vector C, some combined vector, and we'll figure out what that is right now. 100 minus 40.1 equals C vector. So C vector ends up equaling 59.9 is our C vector. And it's often helpful to rewrite your diagram after you've combined any two vectors. So we've got the up direction. We still have our x direction. We didn't do anything to By. By is still there. So let's put By back on our diagram. By is chilling with 7.3. But we've combined Bx and A. They don't exist anymore in our diagram. We've combined them into one new vector. And that vector was positive, so we know it is directed positive direction, vector C. And that one equals 5, 9.9. So now we can go ahead and use rule number 2 to combine these two into one independent vector, and I suppose we'll have to call that vector D. Run out of vector names here. Vector D. Where vector D is going to equal the square root of by squared plus c squared. So in this case, D equals the square root, D vector, the square root of 57.3 squared plus 59.9 squared. So our D vector has a magnitude of 82.9 degrees. We have to stress that that's the magnitude. We haven't gotten a direction out of that yet. In order to get the direction, the theta, which it's lifted above the x-axis, or you could go ahead and you can get the angle from the y-axis if you want to flip your trig around. To get our theta, because I prefer the x-axis, theta equals arctan, or the tan inverse, of opposite, which is going to be by vector over c vector, which is going to be the arctan of 57.3 over 59.9, almost 1. So that should tell us that it should be close to 45, because tan inverse of 1 is about 45. Being able to recognize patterns like that is extremely helpful, because if you know your answer should be about 45 degrees and somehow you're getting 67 or 80, you know you did something wrong. Your calculator may be in radians. You may need to go recheck your work. Predicting your answer is always a good choice. So our theta ends up being 43.7, very close to 45, which means that our final answer is that our A vector plus our B vector gave us some D vector, which has a magnitude of 82.9 directed at 43.7 degrees above the positive x-axis. And that's my final answer. So all that was figuring out how to combine B with A. By combining B with A, and do through all these steps, we ended up with this vector at this angle. Being able to attack vectors regardless of their angle, regardless of how they're arranged, is essential for physics. Absolutely essential, because you get to things where you have 3 or 4 different vectors at different angles, and you're going to need to be able to combine them. So, as time goes on, we'll get into more of those types of examples. Thank you very much, I hope you enjoyed the video.